we've all heard that the area of a circle is just pi r squared. But what is pi and what is r squared? Well, in the case of this circle, we can actually make a square with side lengths r, and r, of course, is the radius of the circle, or just half the diameter. And this square right here actually encloses an area r squared. So this is what we mean when we say r squared. And now if we're trying to figure out the area of this circle, what we can do is we can notice that, well, it must be bigger than r squared because r squared sits quite nicely and comfortably within this area. And so we have a solution to this, which is we also have an upper bounds for our approximation for the area of the circle, and it's this bigger square. And this bigger square nicely encloses the circle at 4 points, and the reason it does that is because the side lengths of the square are the same as the actual diameter of the circle. And that's true actually in both directions, for this side and for this side. And conveniently enough, when you square the diameter, you get 4 little r squareds. And so the circle, since it's enclosed within this area, must be somewhere between 1 times r squared and 4 times r squared. And so the question is, well, what number do you multiply it by? And of course we know the answer is pi, but pi is 3.1415 and so on. And how do you go from, working with integers like 1 and 4 to being able to tell exactly that it's such a specific number as 3.1415 all the way on to infinity? How do you go about doing that? Well, this problem actually showed up on the doorstep of the famous Greek philosopher and mathematician Archimedes. And Archimedes decided to try to approximate the area of a circle using polygons. And this was a genius idea because you can divide regular polygons into triangles of equal area. And triangles can be calculated, their area can be calculated using the formula 1/2 base times height. And in the case of a regular polygon, or the hexagon in this case, you can multiply what you find this area to be by 6 to get the total area of the hexagon. And Archimedes created an inscribed hexagon in this circle, and then he inscribed the whole thing in another hexagon. He said, well, this bigger one, which I've represented fully on the right side, and this smaller one, which I've represented on the left side, when I average these two, I'll get something that kind of somewhat approximates the area of the circle. And so he did that, and he got some number, but instead of just writing that number out, he remembered to express it as some number multiplied by the radius squared. And what I mean by that is, in this case, the radius of the circle, which you can still see is represented with any one of these lines, squared gives you the area enclosed right here. And what Archimedes recognized was that since the radius squared is still smaller than the hexagon, he could find out the area calculated using these triangles and then divide it by the radius squared in order to get what he called pi. And pi is the number that you have to multiply the radius squared by to get the area of this polygon. Now, when he averaged the bigger one and the smaller one together and expressed it as something times the radius squared, he discovered that it wasn't in fact 3, it was 3.03. And he became curious about this. He wondered, well, if I make my approximation better than a hexagon, for example, maybe an 18-sided polygon, and you can see the error for the circle here is drastically reduced from what it once was, well, will I get a more accurate answer? And in fact, he did. The 18-sided polygon, the smaller one, and the bigger one started to approach the area of the circle from different sides. And so when Archimedes averaged the areas of these two polygons separately, he was more and more confident in his calculation for what pi should be. And eventually, he actually extrapolated this principle to polygons with several hundred sides. This one here is a 300-sided polygon. And when I take the area of all of these 300 triangles and I add them all up, what I end up getting is 3.14159 times the radius squared. And that's very curious because 3.14159 is in fact pi, or at least the first few digits. And the reality is, as you create a polygon with more and more sides, as the sides approach infinity, the area of the triangles, when you add them up, approaches pi times r squared. And so really, a circle is just a polygon with an infinite number of sides, and the area of the circle can be mathematically derived using smaller and smaller triangles and adding them up to find the total area. Thank you very much for watching.